So now, how do we use it, right? How do we use this definition to find our derivative? All right, now, so again, that's the function, and the definition is f prime of x is equal to limit as h approaches to 0 of f of x plus h minus f of x over h. As I was writing this notation right here, I literally tell myself, even though I have done this thing for so many years, I always tell myself it is y2 minus y1 over x2 minus x1, because this is just what slope is. All right, now, there are two big components.
So after we solve this, we'll get an answer, right? But that's just the derivative
Of this,
the slope.
well, derivative is the slope of the function.
But the point.
Plug the x value in, slope of the particular point. Okay, so now there are two big components that I would like to address. The biggest component is likely here, because a lot of people, they are very uncomfortable with the f of x plus h. Now, and I always tell my students, if I ask you, can you find out f of 3? Would you know how to do it? You would say, well, that's easy, right? You just put 3 into the axis. So then if you know what's exactly going on here for f of 3, so that means those parentheses are just containers. If you have a 3, you put 3 into the parentheses. And now what do we have? X plus h. Then we do it. Okay, so the presence of the x plus h, yes, it is ugly, but it is not like terribly ugly. It's just that, do you have the right mind? Do you understand the nature of this x plus h simply being the quote unquote new x value, and you just put them into the x's? Y2, yes, but conceptually, without any specific values. And then what you want to do is that you want to FOIL this out, and you want to challenge and say, why do we need to FOIL this out? And I would say that's an excellent question, and I would answer this question in just a moment. But you want to do this first. And in calculus, a lot of times the justification is not there right away, but in step 2. What is step 2? Well, let's go ahead, pull the definition right here. Well, what's the definition? Well, that's the definition, right? And then we say the highlighted part in green, f of x plus h, right? F of x plus h. Well, what is f of x plus h? This thing right here, right? It's f of x plus h. And let me go ahead, put a pair of parentheses around it. And then minus what? F of x. And I need to go ahead and put a pair of parentheses around them as well. Over what? Over h. Now, this will be the justification of why you will need to do the expansion over here. Because if you look ahead, can you see something? You can cancel some stuff out, because x squared minus x squared, they are gone. Minus 4x plus 4x, they are gone.
Does that work all the time?
Well, they tend to happen this way. Yes, they tend to happen this way, because the likely step that follows is this. You will have all the terms with the h, all right? And then we say, hey, they all have h's, right? So let's go ahead and simplify it. And 2x h divided by h, and this, okay? Because they have h in each of the 3 terms in the numerator, you go ahead and simplify them with h. And now, and only now, you go ahead and execute the limit notation. And by the way, I think I've said it before, thou shall keep writing the limit notation until substitution. Okay, you substitute it, 2x plus 0 minus 4, 2x minus 4. Yes, okay, 2x minus 4. So this is what we call f prime of x, meaning what? So f prime of x is 2x minus 4. That means if you want to know the slope of x squared minus 4x at any x value, hey, you can do it simply with the with this equation. Now, something extra that I'm showing you right here. I can actually make a graph of this quadratic x squared minus 4x, right? The graph is like this, right? Because the two roots are 0 and 4. And I can also tell you the vertex, because the vertex is going to be 2 comma negative 4. Because I put a 2 right there. 2 squared is 4. 4 minus 8. Yeah, negative 4. Now, here's a little thing I want to share with you as well. See the vertex right there? The vertex right here? We always love to ask questions like this. What is the slope at the vertex? 0. Because the tangent line is going to be a flat line with a slope of 0. And now, so what you can do, now if I say, hey, let's just say you have no idea what this graph is. No idea.
Why does it have to be straight? Like, what if I just tilted it a little bit? The slope wouldn't be 0 and it could still touch the vertex only one time.
It won't. It won't. Now I like this question. Now, if I tilt it, okay, tilt it a little bit, it is slightly off from the vertex. So that's why, and that's why we use the word tangent. And that's why I said the definition of tangent back in circles is that it can only touch a point. Every single point on a circle should have only one tangent line. Oh, you are poking the bear, and that is a very good question. And I would talk about this after after I finish explaining this. Okay, you raised a very good question. All right, now, so if I say I have no idea what this graph is, and in calculus, this is often the case. We'll give you a function that you have no idea what the graph is. And we say, oh, can you find the point where the slope is 0? And we say, cool, no problem. The slope is what? 0. Therefore, x is equal to 2. And you say, oh, so where would the function have a point that has a 0 slope? Oh, x is equal to 2. But what's the point? Oh, the point? Well, f of x equals to x squared minus 4x, right? So put the x value back in here, get the y value. So the point is, now, and there's one thing that I would love to address right here. And that is, whenever you get something, I tell my students, every single thing that is coming out from your hand, writing on a paper, any words that you're speaking out from your mouth, you need to know what it means. This 2x minus 4 means what? It's a slope of x squared minus 4x at any x value. What is x squared minus 4x? The function itself. The function itself that is representing all the points. Meaning what? If you have an x value, you can always find the y value. Always. Okay? All right.